Hi students. All right. So, another e-learning day. Oh my gosh, it is beautiful. I truly hope that most of you will get outside in that snow. I am not giving you very much today because honestly, I want you to get outside in that snow. Of course, I'm properly dressed for it, but it is a beautiful snow to get out and play in. So, sorry for the glare. I keep trying to figure out a way to avoid it. You know, the joys of wearing glasses. All right. So yesterday's pun was, if you are against money, then you are anti-money. Anti-money. ANTIMONY is the answer to the pun for yesterday. So, today's pun, oh crud, I forgot to get it out before I started the video, so sorry. Man. Okay. Let's see. When people are sick, they go to the doctor, hoping the doctor will. And there's actually two possible answers for that one. Either one is fine to pick, either one. So when people are sick, they go to the doctor, hoping the doctor will. There you go. All right. So there's your pun. We are done with lesson 1, and we're ready to move on about, lesson 1 was about valence electrons, introducing valence electrons and energy levels, and the valence electrons are the ones responsible for bonding, creating bonds. And now we're going to learn about how those valence electrons could create bonds. There are actually 3 ways that bonds can form, and it's based on those valence electrons and whether or not it's a metal, non-metal, metal to metal, non-metal to metal, non-metal to non-metal. So you have some new vocabulary. I'm going to go over the terms. Bond, which is from the previous lesson as well, you still need to know. It's a force that holds atoms together in a compound. Okay. A chemical formula, those are a group of symbols and numbers that represent the makeup of the compound. So some common chemical formulas you might know right here. H2O, water, 2 parts hydrogen, 1 part oxygen, H2O. CO2, carbon dioxide. CO is carbon monoxide, but CO2 is carbon dioxide. And here's one that you may not be familiar with. This is a really important carbohydrate. It's sugar. C12H22O11. Carbohydrate. Carbo for carbon and hydrate for bonding to water molecules. Do you see that the hydrogen is twice as many atoms as the oxygen? Are you familiar with the word hydrate? What do you do when you hydrate? You drink water. Carbohydrates. Carbon attaching to essentially water molecules, carbohydrates. So C12H22O11 is sugar, just common sugar. All right, so those are chemical formulas. So they're symbols, the element symbols, and there are numbers involved. These are subscript numbers. These down here called subscripts. When there's a number in front of it, those are going to be coefficients, and we'll talk more about those later on. So this first lesson is about one way that elements can bond and form compounds. And this one way of the 3, one of the 3 is called covalent bonds. Covalent. Think about the word covalent. sharing valence electrons. Covalent. Sharing valence electrons is what they're going to do. And the goal is for each atom to have access to an octet, or to become stable, to become chemically stable. I'm sorry, my parents have vaccines today, and I'm checking in with them. You know, they're 86 and 84. So I'm checking in. Sorry about the phone dinging. I need to get back with that and see what I can do to help out with that. Okay, so covalent. Covalent bonds create molecules. So we typically hear water being called a water molecule. That's just one single molecule of water, which is based on covalent bonds. Page 130 in your book, which I'm going to be assigning the guided reading, and that's all you have to do today. Page 130 in your book does a really nice job of showing you and explaining to you in a diagram using dot diagrams, which we've been doing, using those dot diagrams to show you how they would pair up, and then each one would have access to an octet, except for, remember, hydrogen and helium just need access to 2 because they're in that first energy level. So on these, they're going to show you how a hydrogen molecule, where a hydrogen bonds with another hydrogen, they have access, both of them have access to the 2 electrons because they're sharing those 2 electrons. Each one gives 1, and they share them and have access to both of them. Therefore, both those hydrogen atoms are stable because they're sharing those 2 electrons, and that applies to the stable atom. Okay, so you're going to have to think about things not only about it being, those are the hydrogen and helium are the only ones that want 2. Everybody else wants 8. Okay, so don't be confused by that. It shows you how CO2 is a covalent bond, and it's going to show you how each oxygen and the carbon atom has access to 8. So pay attention to those dot diagrams and see how they're sharing, and actually then each electron, remember those, we were trying to see who was unpaired, and that was why you had to do them in that specific order, so you can see who still needs a partner. So it does a super nice job in that diagram, so please pay attention to those diagrams. It really explains things nicely. I'm a visual learner, so I guess that's why it makes sense to me to look at, don't just look at the diagram, read the boxes about what's going on in those diagrams, okay? And then page 131 does a nice job of explaining polar molecules. The water molecule is so unique. It is polarized. It has a positive side and a slightly negative side. And that's what makes it the universal solvent. We've talked about that. Now you're going to see it. You're going to see why. You're going to understand that electron movement and why that creates a slightly negative and slightly positive side. We're ready to understand that now. You already knew it was a polar molecule because we've already talked about that. But now you're going to get the understanding of why is it polar? Why does it have a slightly negative and a slightly positive side? Why is that? And it's the movement of those valence electrons and the sharing of those valence electrons, the unequal sharing of those valence electrons. So that is on page 131. It does a super job of comparing CO2 to H2O and why H2O is polar and CO2 is not. Okay, so you're going to be doing the guided reading for pages. Let me get some page numbers for you. Yeah, okay, went back too far. Okay, it starts on 128 and it ends on 132. Okay, so 128 to 132, guided reading. I am not, do I need to have you submit those? I do not need to have you submit anything to me today. Make sure you get those done. I'm going to go over them with you tomorrow. and then you'll be doing probably some content practices. Just depends. If we're at school, I would like to do some of the startup lab stuff, but I need to go into the school to see what I actually have at school and what I picked up and see if I have everything I need. So, all right, get your bell work done. We'll be turning those in tomorrow. So, get those caught up. I've been giving you the answers. Tuesday was actinium. Yesterday was antimony. And then today's pun is when people are sick, they go to the doctor hoping the doctor will. Okay? Have a great day.